All right, so we saw how dams or why dams are built for flood control, water supply, recreation, hydroelectric use. Um, but dams can also have negative impacts on that aquatic system. Um, for example, this image is a little hard to read, but for each state we have two numbers. The upper one is the number of native fish in that state, and the lower one, the red number, is the number that are endangered. And so you can see in California, where aquatic systems have been altered quite a bit, 42 of 58 are endangered. Um, Nevada, 39 of 43, 22 of 26 in Arizona, 11 of 26 in Utah. So these western states that are typically quite dry, a high proportion of their native fish populations are in trouble. There are some endangered ones in other states, but not as much of a proportion. For example, you see in Tennessee 40 of 257. It's a real hotspot of aquatic diversity here in the Mid-South and Southeast. Um, so, again, problems associated with dams. You have to alter that riparian habitat. Basically, you're going to flood it. Um, and Of course, people who lived in these areas, not so much out west because they were mostly just in desert areas and not many people lived there, but in the east, mid-east, midwest and such, a lot of people were displaced when you put these dams in. Um, Obviously, a dam is a very significant problem for migrating fish. They cannot get past it. Um, Out in the Pacific Northwest, where you have salmon that migrate up the rivers, they've attempted to build structures called fish ladders that they can basically swim up and over the dam. And they've even resorted to trucking the fish around the dam. But in some of these places, the salmon populations have been significantly negatively impacted. Flooding brings sediment downstream, which is deposited typically in floodplains or at the mouth of the river, the estuary. And this brings nutrients and helps build soil in these areas that normally flood. Well, when you build a dam, the waters come down and they hit the lake, they slow down, and the sediment accumulates behind the dam. It does not get downstream. So essentially, dams, these reservoirs, will ultimately fill up with sediment. It's a process that can take a while, but they inevitably do slowly accumulate and become shallower because of that. Um, Again, the benefits: flood control, water for irrigation, use of towns, etc., electrical generation, um, recreation. All right, let's look further west in Los Angeles. So LA is in this basin or area surrounded by mountains on basically three sides and the ocean on the other side. And so it comprises about 6% of California's habitable land. Um, 6/100ths of a percent of California's stream flow flows through Los Angeles. Gets about 13.5 inches of rain a year, so it's just a little bit more rain than a desert, so pretty dry. And it's very seasonal, by the way. It mostly falls in the winter and it doesn't fall at all in the summer. You can see by comparison, Nashville gets about 46 inches of rain a year. Um, so 45% of California's population, though, lives in this area. So 45% of the population, 6/100ths of a percent of the stream flow. You can see a significant disconnect there. There's not enough water to support the number of people that live in Los Angeles. So they have to bring in lots of water. And so just as New York City gets theirs from upstate, California gets theirs from various sources. We've already said how it comes from the east via the Colorado River, and it comes from the north by aqueducts that bring it from reservoirs up in the Sierra Nevada mountains. Um, and so you can see the red line here from Colorado River, the yellow line from up north. That's the main sources of surface water for Los Angeles. They also tap into groundwater that they have and the relatively small amount of surface water they have locally. One of the negative consequences is Mono Lake is one of these lakes further north that they use as a source of water, and so they've been basically drawing water, and the water levels have declined over time. And again, it's connected to LA by this 350-mile pipe, basically this aqueduct. And the lake has been drying up, and it leaves behind this layer of salty sediment as the lake shrinks, and you can see some of these rocks and such are encrusted with these um, um, sediments that are left behind. There's one of the pipes that brings water. It's a good sized pipe. You can see the camper by comparison up over in the mountains being pumped. Um, so the Los Angeles Aqueduct is one of these pipes that brings water in, um, brings in some of the water. 13% comes from local groundwater, 69% from the Metropolitan Water District, which gets it from various sources. Um, Now, this number, I'm guessing, has changed since I created this slideshow. Water originates from recycled water. That is, they're taking wastewater and cleaning it up and reusing it. So it would be as if the water that comes out of the White Creek wastewater treatment plant that we went to, if it was just being, instead of being put back into the river, it was put back into the water supply. And people sometimes cringe about that, but if you do a good job cleaning up, it is basically water. It doesn't really matter where it came from. Let's skip that. Again, this just shows how these cities in the Southwest and California have to resort to multiple sources of water. Here in Nashville, we get our water from the Cumberland River. That's pretty much it. But they get it from groundwater. Um, they get it from these distant reservoirs. Um, they even have some, in some places, starting to desalinate that water. They're reclaiming water, again, reusing that wastewater. So they're having to get really creative about supplying enough water to these populations. Because some of these places, again, are out in the desert. Palm Springs, California, you can see it's in the middle of a desert, but it's this green oasis. And again, that's because they're sending all sorts of water there that's not there normally. Um, and so you ask yourself, well, is this a good thing to do? Is it a sustainable thing to do? To have a golf course out in the middle of the desert in Scottsdale, Arizona, where again you get less than 10 inches of rain a year, and in the summertime you routinely have temperatures well over 100 degrees. That artificial pond there is going to be losing a lot of water in the summertime and throughout the year for that matter because of evaporation. All right, so I've already talked about this a bit. Again, here's this Colorado River Basin watershed, and a lot of that water is allocated to be used, and those allocations were determined back during a relatively wet period in the 20th century. And so it's not unusual that by the time you get to the estuary where it drains into the Gulf of California, it's often dry or just a trickle, and there's an estuary there, a wetland, that has been compromised significantly due to a lack of water coming down the river. All right, how can we use less water, maintain water quality? Well, if you're in the desert Southwest, there are cities and towns that are encouraging people to ditch the lawn and go with xeriscaping, desert landscaping, sort of accept that you live in the desert and having a nice green lawn really does not cut it because it's a waste of water. Um, and so you embrace the desert plants and use them to do your landscaping. Now you might think, okay, it's nice to have a lawn. Well, what you can do is the homeowners do the xeriscaping, and perhaps the city will maintain parks with grass in it, and so people can have places they can go to frolic on the lawn. But overall, the town is using less water, and so here you can see in southern Nevada, they're encouraging people to remove the grass to save water. I'm going to skip this. This was a paper that we read before. We didn't get to this year about this desert area um, that is slated to be developed. And again, it would have lots of homes and things like this. Again, golf courses in the desert, and you have to again ask yourself, is that a sustainable practice? Because there are some springs in this area, in this desert, where you basically have an oasis, and if they were to begin tapping into the groundwater in these areas to supply these developments out in the desert, the springs would run dry, the oases would run dry, and the species that live there would not do so well, including this one called the Moapa dace, which is this fish that's only found in these springs in southern Nevada. And if the springs dry up, no more home for the fish. Pervious concrete, to take those impervious surfaces and allow water to run through them and get into the groundwater and not end up in the stream so fast. If you've ever, this is not from there, but if you've ever gone over to the Commons, the Vanderbilt area, where the living area, they have a lot of this impervious concrete there. Um, Rain gardens are a way to get water into the ground and not have it run over the surface and into the storm drain. And they're just low areas on your property where you plant certain kinds of plants that that look nice. And again, the goal is to keep the water from getting into the rivers too quickly and into the ground. And they come in various forms. Here's one where the parking lot is geared so that the water runs into the rain garden and not into the storm drain. One in somebody's front yard. This is one you've probably seen. If you go over to Publix there off of Harding Pike, it's there. And there's this sign here, which I don't have the sign posted there, but that's a rain garden where the water from the parking lot runs into it to get to the ground. Rain barrels, you can collect the rain from your the water from your downspouts, and instead of again having it just go into the storm drain, you can collect it and then use it to water your plants when it's not raining. This program called Green Streets, where again you put essentially rain gardens along the side of the street and the sidewalk, and you get the water to get into the ground instead of the storm drain. And so you can see the water will flow down the street into the rain garden, and hopefully most of it will be absorbed. Now, if there's too much, the excess will run off the rain garden down the storm drain because you don't want to have flooding on your street. But again, the goal is to get as much water into the ground as possible. And so here you see one along this street. And so the water can flow into these inlets here. Farming can also be much more efficient in terms of its irrigation to get more of the water to the plants and less of it just spread over the ground so that it evaporates. In our homes as well, we can be more efficient in our water use. Have you ever been driving down Woodlawn or Estes and it's a day where it's raining and someone's irrigation is going off? I've seen that many times, and so they just have it on a timer to come on no matter when. And so that's kind of a dumb system, you might say. You could have a smarter system that can know when it's raining and the lawn does not need to be watered. Our appliances, top-loading washers and such are much more efficient. Shower heads can use less water, and of course, in the process of using less hot water, you'll also save energy. Tankless water heaters are ones that heat water as soon as it's needed, right when it's needed, instead of just having this large tank of water that keeps it hot all the time like most of us have. There's a tankless water heater. And so again, all these different ways. In agriculture, we can use drip irrigation to get more of the water to the plants and less of it evaporated. If you're in a landscape that simply doesn't have much water, you can shift to dry land farming where you grow plants and raise animals that don't need as much water. In towns and cities, we can have our efficient appliances. If you're in a desert landscape, xeriscaping and eating down the food chain. How does that save water? Well, if you eat more plants and fewer animals, that might seem a little counterintuitive, but when you eat a lot of meat, it takes a lot of food to feed those animals and a lot of water to grow those crops. Okay, I think that's it, and I am out of time.